Consider a circular loop placed in YZ plane. A steady current I is flowing through the circular loop. And x-axis is the axis of the loop. So we got here three axes, x-axis, y-axis and z-axis, and the current carrying circular loop is placed in the YZ plane and axis of the loop is along x-axis. When the current is flowing through the loop, the magnetic field is produced. Today we are going to obtain an expression for magnetic field at a point on the axis of the loop. When the steady current is flowing through the circular loop, the magnetic field is produced. We need to find expression for magnetic field at point P on the axis of the circular loop due to entire circular loop. Let R be the radius of the circular loop and O be the center of circular loop, and the distance between center of the loop and the point P is equals to x. Consider the small element dl on this circular loop. So let us consider at two places, here and here. So this is dl, small element. Here also we had selected dl. The small element dl is in YZ plane. Now we will join dl and p down as well as. The distance between the small element dl and the point P equals to r in both cases. Since the point P is equidistant from both small elements dl, therefore the distance between dl and P is given by r, which is equals to under root of x square plus r square. In first case as well as in second case, r equals to under root of x square plus r square, where capital R is the radius of circular loop. Now call this small element by some name like C. So dl is a very small element, and down also another small element, call it as a d. So Cp nothing but vector r. It is a vector quantity denoted by vector r, and magnitude of this vector r is given by under root of x square plus r square. Now what is dl? The dl is current element, therefore I can, so it is a current element. So what is the current element? dl is the current element. So what is current element? Current element is nothing but small portion of the conductor. It is a small portion of conductor, and plus current is passing through it. And it is a vector quantity. So dl is a vector quantity. So we are having Cp, that is equal to vector r. Vector r nothing but Cp, and r cap is a unit vector in the direction of Cp. Now on this circular loop we can select so many small elements like this. current is flowing through this coil, and we are considering so many small elements present on this loop, and every small element is producing magnetic field. Magnetic field produced by small element can be obtained by using Biot-Savart law. Now let us understand what exactly the Biot-Savart law. Now this is a conductor, and through this conductor current is flowing, and dl is a small current element, and magnetic field is produced at the point P, and dB is the strength of magnetic field. Biot-Savart law can be written in two forms, in scalar form and in vector form. Biot-Savart law in scalar form is given by the magnitude of magnetic strength is given by dB equals to k into IdL sin phi upon r square, where phi is the angle between dl and vector r, where k is the constant of proportionality. K is given by mu naught upon 4 pi, that is equals to 10 raised to minus 7 Tesla meter per ampere. In vector form, mu naught upon 4 pi I dl cross r divided by r cube. So this is a vector form Biot-Savart law. If you want to have more detail about Biot-Savart law, please visit my playlist. I have already given a detailed explanation about Biot-Savart law. Therefore, by using Biot-Savart law, we can find out magnetic field at the point P. This is the point P. At point P, we can find magnetic field due to small element dl. So, in scalar form, dB equals to mu naught upon 4 pi multiplied by I dl sin phi divided by r square, where phi equals to 90 degrees. Therefore, dB equals to mu naught upon 4 pi I dl sin 90 divided by r square. dB equals to mu naught upon 4 pi I dl upon r square. This is nothing but magnetic field at point P. At point P due to dl, a single small element dl. Now dl will produce the magnetic field at the point P. Similarly, other small element, this, every small element. There are the hundreds of small elements present on this circular loop, and every element is producing magnetic field at the point P. This is the point P. So we need to find the total magnetic field produced by all current element. Now the magnetic field produced due to the current element at the point P. We need to find what is the direction of this magnetic field produced at the point P. So this element dl is producing magnetic field at the point P. So we want to find what is the direction of magnetic field due to this current element dl. So dl is producing magnetic field, and it is a current element. So I have written the dl vector, and dl is producing magnetic field, the small magnetic field, that is a dB. So what is the direction of dB? So the direction of dB is nothing but perpendicular to the plane formed by dB and vector r. So that plane, that is nothing but here shown by some color. This is the plane, and this plane gives the direction of dB. So finally, we got the direction of magnetic field due to small element dl. Call this angle, that is the angle OPC. Angle OPC equals to theta. So this angle is theta. And even this angle is theta. So here is the angle theta, here is also angle theta. Now we must find the components of dB. dB has the two components, one is the horizontal component, another is the vertical component. So resolving dB into horizontal and vertical component. So dB is the final direction of magnetic field produced by the current element dl. Now join, complete the triangle, call this point as a L and call it as a M. So we got the triangle PML and this is 90 degree. From this triangle, sin theta equals to ML upon PL. Therefore, ML equals to PL sin theta. Therefore, ML equals to PL, nothing but dB. So dB sin theta. So ML is also a vector quantity. So ML equals to dB sin theta. This gives horizontal component of magnetic field due to the current element dl. Similarly, from this triangle PML, we can find out the cos theta. So cos theta equals to PM upon PL. Therefore, PM equals to PL cos theta. Therefore, PM equals to, what is the PL? Vector dB. Therefore, PM is also vector. So vector PM equal to dB cos theta. So we got the component along x direction, that is nothing but vector ML, that is nothing but dB sin theta, and the component in vertical direction, nothing but dB cos theta, vector dB cos theta. This circular coil is symmetrical about its axis, and dl is the current element at the point C and dl dash is the current element at the point D. These both the current elements are equal and opposite to each other. Both the elements will have same value of horizontal component, but the direction of vertical component, that is the direction of perpendicular component, are not same direction. So example, one is directed along the PM, so another one is directed along the PM dash, that is a d vector dB cos theta. So the perpendicular component due to dl is PM along the PM direction, and perpendicular component due to dl dash is along PM dash, that is they are equal in value but opposite in direction. Therefore, perpendicular component due to the current element dl and dl dash are opposite in nature, equal in value, therefore they cancel each other. Like this, on this coil there are the large number of equal and opposite current elements like this. They are equal and opposite element, and the perpendicular component due to all these will cancel each other. So the net magnetic field due to all current element is only because of the horizontal component, that is the dB sin theta. The vertical or perpendicular components do not contribute to the magnetic field. The first current element will produce magnetic field dB1, and second one will produce magnetic field at the point P dB2, like this third element dB3, and so on. So total magnetic field B is nothing but addition of magnitude of dB1 plus magnitude of dB2 and so on, the magnitude of dBn, where dB1 is nothing but magnitude of vector dB1 and dB2 is nothing but magnitude of vector dB2 and so on. Therefore, the vector dB sin theta, if you are considering only magnitude, you can write dB sin theta because we are interested only in magnitude. Therefore, dB1 equals to dB1 sin theta and dB2 equals to dB2 sin theta and so on till end dBn equals to dBn sin theta. We are considering their components, component of dB1, component of dB2 and so on, component of dBn we have taken here. Now the total magnetic field due to all current element is nothing but addition of all this magnetic field, that is dB1 sin theta plus dB2 sin theta and so on till end dBn sin theta. In short and sweet, it can be written as summation of dB sin theta. And in terms of integration, we can write B equals to integration of dB sin theta. But from Biot-Savart law, what is the value of dB? dB nothing but mu naught upon 4 pi into IDL upon R square. So this value we can use now. Therefore, B equals to integration of, in place of dB, mu naught upon 4 pi I dL upon R square into sin theta. Since we have R equals to under root of x square plus R square, therefore R square equals to x square plus R square. In above expression, mu naught upon 4 pi is constant, current flowing through the coil is also constant, and x and R also constant unless and until you change them. So during the experiment, the value of x and R are not changing, therefore they are constant, and theta, sin theta is also constant. So only variable is the dL. So we took all the constant terms out of the integration and integration of dl only left. Integration of dl is nothing but total length of the coil, and so integration of dl, total length of the coil, that is nothing but 2 pi r. Therefore B equals to mu naught upon 4 pi into I upon x square plus r square into sin theta multiplied by 2 pi r. From this diagram, in triangle POC, sin theta equals to r upon small r. Mu naught upon 4 pi I upon x square plus r square, and sin theta nothing but r upon r multiplied by 2 pi r. Now we need to simplify this. So b equals to mu naught upon 4 pi as it is, I is as it is. Here is a 2 pi r square divided by x square plus r square into 1 upon r. Here in place of r we can write down under root of x square plus r square. In place of small r I have written under root of x square plus r square. So this becomes b equals to mu naught upon 4 pi multiplied by 2 pi r square. Here I can write here. So mu naught I upon 4 pi into 2 pi r square divided by x square plus r square raised to 3 by 2. So finally we got the expression for magnetic field at the point P. At the point P. So finally we got expression for magnetic field at the point P. Here the magnetic field is nothing but given by the expression B equals to mu naught I upon 4 pi into 2 pi r square divided by x square plus r square whole raised to 3 by 2. That's all in this video. Meet you again with next topic in the next video. Before saying goodbye to you, I would like to request you like, share and subscribe the channel. Meet you again with another topic. Till then, wish you good luck. All the best.